Okay, we'll start chapter 3, linear equations in two variables. All right. So, what does linear equation mean? So, at first, we studied about quadratic equations, right? Quadratic equations were like ax squared plus bx plus c equal to 0, which we studied in chapter 2. And the graph for this, if you plot it in the graph, it comes out somewhat like this, a parabolic graph, right? Now, this is one variable which is only x, okay, and then it's a quadratic equation because the highest power is square. Now, if I write an equation with two variables, x plus by plus c equal to 0, suppose, then this is two variables because there's x and there's y, and then the highest power is 1 only, right? We can't see x squared nor y squared, so we call this as linear equations in two variables. Linear equation literally means we can say this also, linear equation. If it's just linear equation, we could even say this, but then we're talking about linear equations in two variables, so one variable, two variable, like that. Okay, so if we plot a linear equation of two variables in a graph, what it would look like is a straight line from one point to the other point. That's what we will get. I think you studied in grade 9 how to plot graph using a linear equation. Anyway, that's how we get if we draw a linear equation in a graph. Okay, so in this chapter we will be studying about two linear equations of two variables. Theta. First is this one, let's say a1 being any number, okay, plus b1 being any number, plus c1 equal to 0. This represents one line, and then there will be the second one where a1, b2 and c2 are also any number. It can be any, but x and y should be there. Okay, so this represents one line, and then this represents another line. Got it? So we'll be studying about two equations, both of which are linear equations in two variables. So if we draw this in graph, the first one, it'll come up with straight line. If we draw the second one also, it'll come up with straight line, right? So there's three possible outcomes. First outcome is that the lines will meet at a point. If I draw the equation of this and the equation of this, and then they meet at a point, one particular point. Second option is that the lines, they never meet parallel. Okay, they never meet, they'll just go on and on. No matter how much you extend this side or this side, so they'll never meet. And the third option is, let me use, okay, one line here and the other line also here. Got it? So it's like overlapping each other, on top of each other, overlapping each other, or it's called coincident. Okay, so there's three possible outcomes. One is meeting at one particular point, one is parallel, never meeting, one is overlapping on top of the other. Okay, so this, where they meet, see, this is what we're going to do. Okay, we're going to find the values of x and y in most of the equations. So we'll be solving this, and we'll be getting x equal to something and y equal to something. Okay, so x equal to something, y equal to something literally means the point of intersection. So this will be a coordinate. You do know how to plot graphs and what are coordinates, right? There will be an x-axis from here, y-axis from here, and then we'll find the coordinate, that's xy. So the value of xy from which we will get after solving all this will be the point where the two lines intersect each other. Okay, so as you can see, that's for intersecting lines. So if they don't meet at all, it literally means there will be no solution. So in case these kind of lines are there, you will not be able to solve also. Either x and y values you will not get. Okay, so this kind of, when we go on, I'll teach you how to find the solutions and everything, so you don't have to worry about that right now. But then for these kind of parallel lines, there will be no solution. So this there will be one solution, and that one solution, only one solution, and that solution will be unique, right? But for this, there will be no solution at all for parallel lines. And for this kind of lines, see, I told you that x, the value of x and y, is a point of intersection. But here, every point on both the lines are pairs of intersection, are the points where the two lines are meeting up. Every point. So which means, in this case, it will have infinitely many solutions. Which means any point lying on this line or this line is a solution. Any point. Okay. So that's infinitely many solutions. This is no solution because there's no solution, and there's one unique solution. Okay. So this is the full set of what it is. So suppose this is this thing, two equations, right? So in case you want to know if, see, because suppose I give you 2x plus 3y minus 5 equal to 0, and then 4x plus, let's say, 6y minus 10 equal to 0. Suppose I give you two equations, okay? And then after I give you two equations, if I ask you, is these two equations going to meet at one point, or are they going to be parallel, or are they going to overlap each other? You don't know, right? So in order, because we'll have to plot the points, right? So the shortcut method to know if they're intersecting or overlapping or no solution or parallel is to take the value of the number attached to x, which is 2 and 4, divided 2 by 4, we're getting 1 by 2, and then take the numbers attached to y, divided, we're getting 1 by 2 again, and then take the numbers attached to nothing, which is the constants, divided, we're getting 1 by 2 again. So in this kind, in this way, we will know, if we apply this, that, see, a1 is the number attached to x, okay, and then a2 is the number attached to this x, b1 attached to y, b2 attached to this y, and then the constants. So if all three are equal, 1 by 2, 1 by 2, 1 by 2, if all three are equal, it means it has coincident lines or infinitely many solutions. Coincident lines means overlapping each other, okay? So this is the one. So if you take this one and plot the graph, they will overlap each other, okay? That's what it means. So these are the shortcut formulas to know if they're intersecting or coincident or parallel. So coincident means infinitely many solutions on top of each other. Intersecting lines means they meet at one point and they will have a unique solution. And then this is parallel lines and they will have no solution. So this, I hope you understand, because in question I'm giving you all this three stuff for all three, like even for intersecting lines, sometimes they will ask not intersecting, but they'll just ask, is it a unique solution or not? So you will have to know that intersecting and unique solution, literally the same thing. Okay, exactly. Sometimes they might even say exactly one solution, just to confuse you guys. Coincident and infinitely many solutions, same thing. Okay, coincident means overlapping on top of each other. Infinitely many solutions means it will have infinitely many solutions. Parallel lines means parallel and they will have no solution. So sometimes they might ask, like, what kind of is this? Is it an will it have infinitely many solutions, no solution, or unique solution? Then you will have to answer according to that. Okay, and sometimes they might ask, is it intersecting, coincident, or parallel? So you will have to answer according to that. And last but not least, this consistent, inconsistent literally means, consistent means there's two lines, right? I've already told you. There's two lines. If the lines are dependent on each other, okay? Which means if they have an solution, x value and y value, if they have a value of x and y, a, okay, even if it's a single one, then they're consistent. It means the two lines are dependent on each other. So obviously intersecting lines, they meet at one point, so that point is the value of x and y, so consistent. Infinitely many solutions, all the points on the line are values of x and y, so obviously it's consistent because they have literally infinite number of solutions. And then parallel lines are inconsistent because they don't have any solutions at all, so they're independent of each other. So that is what it is. Okay, so let's start exercise. See, the thing is exercise 3.1 graph. So I don't think like, since everything will be MCQ, we don't have to study that, but questions based on graphs might come, so I will have to make extra questions for that. So I'll do that by the end of the chapter. I'll give it to you. Exercise 3.2, also question number 1 is graph. The questions which I'm going to skip are mostly graph. Okay, and since we don't have time, I'm going to be giving you a lot of homework nowadays. So first, a1 by a2, let's try to find it out. A1 is 5, a2 is 7, right? Next, b1 by b2, let's try to find it out. Minus 4, 6, so 2 by 3. So literally, we already know the answer because a1 by a2 is not equal to b1 by b2, right? So if you look here, a1 by a2 is not equal to b1 by 2 is intersecting lines or unique solution. Since it's not equal to b1 by b2, I don't know what does the question say. I kind of forgot what the question said, but I think it says intersecting or unique solution. Anyway, question data. By chance, are those intersecting lines or coincident lines or parallel lines? You will have to write those according to that. If the question is asking, is it unique solution or infinitely many solutions? No solution, you will have to write according to that. Okay. For the timing, I'll just write in or. So this intersecting line. Therefore, the lines are intersecting or has a unique solution. Let's just keep it like this so you guys will understand better. Okay. So Roman number 1 is that. Since this is way too easy, I'm just gonna leave it. So the ones which are missing in question number 2 is your homework. I will not be checking it. You don't have to submit it in Google Classroom or anything else, but I will be checking your notebook, so make sure that's there. And I don't want Roman number 1 and then gap Roman number 2, 3, and after this leave some space for doing Roman number 2, 3, 4. Okay, Roman number 2 and 3. Now let's do question number 3. Question number 3 also leave some space for Roman number 1 and 2. That will be homework. So first, I'm gonna take this and simplify this. Okay, so that it becomes easier for us to calculate. So if we take LCM, it will be 6, 3 to the 6, and then 3 to the 9, and then 5 to the 10. I hope you guys have not forgotten how to take LCM. So this will become 9x plus 10y equal to 6, 7, 42. So this and this we will try to compare now. So a1 by a2 is equal to 9 by 9. So cut, we're getting 1. Next, b1 by b2 is minus 10 by 10. Cut, we're getting minus 1, which is not same at all. Remember, you have to take the minus sign also. Okay, the number attached with y is minus 10, not 10, because the format of this formula is depending on this equation, where everything is plus. Okay, everything is plus. That's why we have, if there's a minus, the minus is attached to the number. Okay, so minus 10, so minus 10 is here. And yes, in case you're getting confused, the 7 and 14, it doesn't matter if it's this side or this side. Okay, but if 7 is this side, 14 should also be this side. If 7 is this side, then 14 should also be this side. You have to remember that. Okay, it doesn't matter if it's this side or this side, but wherever the up one is there, the down one should also be there. Okay, if it's not there, you have to arrange it like that. So here also done. Since a1 by a2 is not equal to b1 by b2, same reason. Okay, the lines are intersecting and has a unique solution. Anyway, I will do one last question from question number 3. That will be question knowledge. I think I forgot. Yeah, homework is not pretty. So that's question number 3. Question number 4 is also graph, so we're gonna leave it. Now question number 5. Question number 5 is quite easy also. So half the perimeter of a rectangle garden whose length is 4 meter more than its width is 36 meter. Find the dimension of the garden. So width, breadth, same thing. Let width be x, so length will be 4 more than its width, so 4 more, right, plus 4, and it's saying half the perimeter of a rectangle. Half is 36, so half perimeter, so perimeter equal to 36. And what is the perimeter of a rectangle? There's 2 lengths, there's 2 breadths. Perimeter means the length of the boundary, right? So there's 2 lengths, there's 2 breadths, so 2 length plus breadth, right? So half into 2 length plus breadth equal to 36. Width and breadth is the same thing. 2 we can cut. So length is x plus 4 equal to 36. 4 I can send it this side, x and x we can add it up. So 36 minus 4, x equal to 36 minus 4 is 32. I can send 2 this side. So if I send 2, it will become division. So it will become 16. Therefore, x equals 16, or width equal to 16 and length equal to x plus 4. Remember that x plus 4. So x is 16. So 16 plus 4 is 20. So meter. That's it. Okay. So let's the next question number 6 is also graph. I suppose the rest of the questions are all graph. So let's leave it at that. Let's start 3.3. Okay, so this is the thing. Okay, 3.3 and 3.4, there's like 2 methods. Okay, and if you were supposed to write the exams, then they sometimes ask you the methods, specific method. So they'll ask you to do it by substitution, or they'll ask you to do by elimination. So you have to use those methods and do. But since you will not be writing exam, they will not ask you any specific. They'll just simply ask you the values of x and y. So right now I'm gonna teach you a method to find x and y. After teaching this method, we will skip ahead and teach you the other method to find x and y. And then whatever method is more comfortable for you, we will do that, because we don't have to know both the methods also. Like, as far as we can find x and y, that's more than enough, because everything is going to be MCQ. Hopefully. That's what the board says. We're just waiting for a question paper, so let's see. So, substitution. This method is called substitution, okay? And even if you don't study, at least you need to have an idea of both the methods, how it works. So this is substitution method. So in substitution method, you're going to take the first equation, x plus y equal to 14. Then you're going to separate x or y. It doesn't matter which one. You will get the same result. So in this case, I'll just separate x, okay, for the timing. Y, if I put it this side, it'll become minus y. So this will be your equation 1. Once you separated x, that will become your equation 1. Next, you're going to bring in the second equation. The second equation is x minus y equal to 4. And then you're going to write from equation 1, you're going to put the value of x, because we got x as 14 minus y, right? So 14 minus y equal to 4. So 14 minus y means minus 2y equal to 4. So minus 2y equal to 4 minus 14y equal to, this will be minus 10 by minus 2. Minus you can cut, y is 5. I'll just do it here, okay? Copy it down from here. After this comes here, okay? Y is 5. Once you get the value of y, you just put it in equation 1. Putting y in equation 1. So x equal to 14 minus y. But y we got 5. So 14 minus 5 is 9. That's it. Okay. So this is substitution. It's called substitution because we're substituting the value of x in the second equation and then doing it. Remember the thing about consistent and inconsistent. We're assuming that everything is consistent. That's why we're doing this, dependent on each other. That's why we can equate one equation to the other equation. Okay, so if it's inconsistent or parallel lines, you will not be finding the answers. Okay, so next this, let's try it. So for example, in this question, like not just consistent and inconsistent, okay, we're assuming that it's a unique solution. So x and y, we're getting, x is getting 9, y is getting 5, literally means in the coordinate 9 5 graph the draw 9 5 x 9 y 5 somewhere around here. So the two lines are meeting there. That's what it literally means. Okay, the answer. Now in this question, if I do the same method, I'll take the first one, that is 3x minus y equal to 3. I'll try to separate x or y. Okay, it doesn't matter. In this case, let's separate x, just to show you how it is. So I don't want the negative here, so I'll bring y this side and everything this side. So it'll become 3x minus 3 equal to y. Minus 3x comes this side, it becomes positive. 3 comes this side, it becomes negative. Minus y goes this, it becomes positive. So this will be our equation 1. Now, we'll write the next equation, that is 9x minus 3y equal to 9. And then instead of y, I'm going to replace it. So 9x minus 3, this one you have to write, right? And just instead of y, I'm going to replace this. That is 3x minus 3 equal to y, 9. Now, what you'll notice is that if I open the bracket, this minus 3 is attached with 3. So wherever this minus 3 goes, the minus will tag along. So minus 3 into 3, 9x, and minus 3 into minus 3 plus 9. Okay, so an interesting thing is that what you'll see is this cuts off. Minus 9 kati jabo, only 9 equal to 9. We were supposed to find the value of x, but somehow we ended with no x or y, whatever it may be, right? So when this happens, and even 9 and 9, we can literally cut it off. So when this happens, it literally means that it has infinitely many solutions or no solution. Okay, that's what I mean. So when you get x value and y value, it's guaranteed that it's intersecting lines and this is the point where they meet up. But when you're getting like this, it's either going to be a no solution or parallel lines or infinitely many solutions. So just to figure it out, now we'll have to do a1. Whenever this happens, you're supposed to do this. a1 by a2 equal to 3 by 9, 1 by 3, right? b1 by b2 equal to minus 1 by minus 3, minus we can cut. Here also we're getting 1 by 3, and then c1 by c2 is equal to 3 by 9, 3 1s are 3 3s are 1 by 3. Since a1 by a2 is equal to b1 by b2 equal to c1 by c2, therefore they are coincident lines or infinitely many solutions. You can write that also. You can write they have infinitely many solutions. So see, the thing is, it doesn't matter what we write anymore because it's MCQ. Actually it mattered, but now it doesn't matter. So just remember the coincident and infinitely many solutions, same thing only. Okay, let's do one more question from this method, and then on the next video I'll be showing the other method, and then we will see which one is we'll discuss which one is easier, and then we'll use the easier method. Okay, so this is the question. What I'm going to do is I'm going to multiply this by this is, see, here is a point, here there's a point, here there's a point, but after the point there's only one digit, after the point there's only one digit. So I'm going to write the equation first. Okay, in case there's this kind of question comes, you're going to do this first, multiplying throughout by 10. Okay, so when you multiply 10 into 0.2x plus 10 into 0.3y plus 10 equal to 10 into 1.3, everything is multiplied by 10, right? Because I can take 10 common and cut the tens, it'll become same thing only. So since there's a point here, and 1 0 is multiplied, it'll just go this side and the point will be gone. So 2x plus 3y equal to 13. Now let's change, either keep x or y this side and then put everything that side. So let me separate y. It doesn't matter which you separate, okay? By the way, it can be x, it can be y, doesn't matter. So this will be our equation 1. Now let's write the next equation. There is 0.4x plus 0.5y equal to 2.3. We can go for the same thing which we just did, multiplying throughout by 10 again. So this will become 4x, this will become 5y, and this will become 23, right? Since I did the stepping here, I just skipped here, okay? So anyway, I hope you understood. Now I'm gonna replace x with this one, right? But 4 is already here, so 4 you have to write. So 13 minus 3y by 2 plus 5y equal to 23. So okay, I'm gonna cut this two because it's multiplication only. But before I cut this two, since some of you make this mistake, whenever there's something like this, okay, outside the bracket, but there's only one number, and inside the bracket there's a fraction. When you open the bracket, whatever it's outside multiplies only the top, only the numerator. It doesn't multiply to the denominator. It will not become 8. Got it? But it will, this 3 will become 12, 40 or 12, or 13 4s are 48. 48, 50. What was 34? 50, 42. Yeah, I think 42. So 52. Yeah, 52. Anyway, these 4 will multiply this and this, but this 4 will not multiply this. In case like you're confused over that. But for the timing, we can cut, so it's better to cut so that the calculation becomes simpler. So 13 to the 26, 3 to the 6, 5y equal to 23. 26, I can send it this side, and 6y plus 5y is minus 1y. 23 minus 26, since I get equal 9, so we'll assume it's positive, it'll become negative. So minus y equal to minus 3. Minus minus we can cut, we got y. So putting y in equation 1, x equal to 13 minus 3 into 3 by 2. See, this is the equation 1, right? So instead of y, I'm putting 3, because y we got 3. So x equal to 13 minus 9 by 2. X equal to 13 minus 9 is 4. 4 by 2 is 2. Therefore, x equal to 2. Got it? So that's what it is. Sometimes they might, since it's multiple choice, we have to look into each and every possibility. So they might ask if when you plot the graph of these 2 points on the graph, what is the intersecting point? So you just have to say that the intersecting point is 2, and y was what? Y was 3. So this is the intersecting point. Okay, that's how it is.